Welcome all. I'd like to start with a quick show of hands. So, how many people here actually have some solar installation on Windows in production somewhere? Well, a few, okay. And are there maybe people here that have had clients that were interested in solar but says, well, we normally standardize on Windows, or is it possible to run it on Windows because our staff knows that? Sounds familiar? Not so familiar? Okay, cool. Just for me to know what your incentive is to be here at all. What I'm going to show here is it's a case study. It's about a website that is mostly running on Windows. It's not strictly Windows. It's not all Windows. We're not a Microsoft-only club. But our platform, our operating system is Windows, and we program on the .NET framework. And we have recently migrated all of our search over to Solr from a database solution. And one of the things we were missing back then when we were making the decisions was a reference implementation on Windows. Many reference implementations for Solr on Linux. And we just would have really liked to have a reference to show it. Look, these guys are doing more or less the same and it works for them, so let's do it. So I'm hoping to present this information for people who come after us and that can show it to their management or their, well, whatever, themselves maybe. There's good news because not everything went well. So there are some learnings here to take away, things that we did wrong and that you may not do wrong when you do this. There's even better news. The story has a happy ending. We are running in production on Solr on Windows right now. We are very happy with it. So now, let's go. So, my name is Teun Duynstee. I'm the software architect over at Funda. Funda is a website in real estate search in the Netherlands. We're by far the largest site in the Netherlands that you can use to search for houses for rent or to buy. And in the Netherlands, we're actually quite big. You might not know this, but in the Netherlands, we're like a household brand. Everybody knows it. Newspapers write about us. So we serve about 10 million page views a day. Most of those page views involve searching and faceting. Faceting is very important in our website. We're only active in the Netherlands. The Netherlands is about 70 million people. We have 3 million unique visitors every month. So apparently many people are looking for a house. The market doesn't really show it at the moment, but they are searching. It's hard to imagine that so many people are actually looking at, well, I guess a part of them is just looking around for fun, looking at the house of the neighbors. Yeah, well, they do. Let's have a quick look at the site, so you know what we're talking about, and then I'll talk about the project we did over the last year. So this is our homepage. Now we're really proud of our auto-completion on the location field, because we force people, before they can search for anything at all, we force them to choose a location, and this was a choice that historically we had to make it because we were just not able to search in the whole of the Netherlands. So we forced them to choose for a location first. It's completely unrelated to Solr. It's a homegrown solution, but if you're interested in stemming and Liebenstein distances and all of that, you will maybe appreciate the work that's going there. If you want to talk about it afterwards, feel free, but it's not about Solr. So you choose a location, then you come to a screen that looks like this. And it's fairly straightforward. You get a list of houses, list of properties that are for sale, and here on the side, like here, there is a lot of facets. I'll switch over to our commercial real estate site, which has an English language version, so maybe you can slightly easier understand what's going on. Here, same thing. There is on the left side there are a lot of facets. Now I'll zoom out again, and you'll see the full page, and you see that's actually, it's a lot of facets. We have somewhere in the order of 20 facets that we standard show, and if you make certain choices, more facets will appear. So it's very heavily relying on faceting. So there's no free text search in our website. So why would you run a website like that with a lot of load on a platform that's not particularly known for its stability, that's supposed to cost tons of money in licensing fees? Let's start with that. Actually, we like it. The Windows platform has great tool support. Visual Studio is one of the best development environments I know. I don't know them all. I like it better than Eclipse, at least. The performance is pretty good, we think. Of course, we didn't compare all the platforms and all the languages to be sure, but we're quite proud of the fairly limited server park we need to run this website. So the performance is quite nice. And then it's not that expensive. You do pay for operating system licenses, but in the total running cost of our operation, you can negligible, whatever. It's not important. It's next to nothing. And then, of course, there are historic reasons. It's all built on .NET right now. Our team knows their way around in .NET. Of course, learning Java would not be that hard, but we're there. We know the tools. We know it. Our system admins, the operations guys, they know Windows. They like how that works. They know the tools. They know how to manage it, how to tweak it if they need to. So there we are. Our technology stack. Windows Server 2003 mostly. We're currently upgrading that to a later version, but that's not very important in this story. We run a Microsoft SQL Server 2005, so that's not the latest and greatest. It's good for us. We don't really care about later improvements. It's ASP.NET MVC framework number 2, if you care about that. And then we have a number of other tools. Some of them are Microsoft-ish. Some of them are fairly uncommon in the Microsoft world. So we use memcached for caching. We use some of the Amazon services for serving binaries. So that's what we do. So how did this work, this heavily faceted environment without Solr? It's actually not so difficult. In the end, it's a table. It's flat. It's very searchable. And it has houses in it, 1 record per house. And you would do a query looking something like this, returning the first 15. So that's easy. And then for the facets, we would add extra columns. Now these columns would have only a 1 or a 0 in them. Only 2 possible values. They are actually not Booleans because you cannot sum Booleans, but they can only have a 1 or a 0. And then we do a query more or less like this. So we use the same where clause and sum all of the facet columns. But mind you, you need a column per value of a facet, so you need many columns there. And we did have that. And then at the same time, of course, this really flat searchable table is not the way we in the backend work with our data. So it's a projection from more relational representation of the information. And while projecting, we can easily do that to multiple databases. So we have a scaled out solution with multiple, more or less identical read-only databases. Or I say we have, but we had. This solution, multiple databases, read-only, and we would be summing all the time. Well, it worked. We were not too unhappy with the performance of this, but there were some limitations. Most important limitation, I think, was that the performance of these queries depends very much on the number of results found. So if you search for a house in Amsterdam, that would normally, there will be maybe 15,000 houses for sale at one moment, that would work. But if you would search for the same, for houses in all of the Netherlands, that would be 200,000, then the query would become slow. And luckily, the Netherlands is not that big. So if we were France or the United States, we would have a big problem with this solution. And then at some day we decided not only to allow searching in houses for sale, but also in houses that have been sold in the last few years. So the set became larger, so we had to do something. So this was the moment where we said, okay, we have to do a completely redo of how we search. The second thing that was bothering us for a while already was that it was so much work to make changes to the facets. So there would be like a column for house has 3 rooms, and there would be a column for is close to park, and there would be a column to has been published in the last 3 days. And these columns, like has been published in the last 3 days, it changes all the time. So we had batch jobs updating the ones and the zeros. So it was a lot of work in operations and also a lot of work in development to change things, to maybe add a new facet or something like that. So that was the reason that we were looking around already for a few years. And we had been looking at some of the commercial search vendors, and they were very expensive. We never really got into negotiating about the price, but they're all products that first try to find out how much you earn before they are willing to quote any price. And then probably when you build all your systems on it, they'll probably be acquired by Oracle or something, and then you're screwed. So we didn't dare to go there. Actually, one of the vendors was Endeca, and they were acquired, I think, 2 days ago by Oracle. So I'm happy we're not there. We didn't dare to go with the commercial stuff. And then we saw Solr, and we were quite enthusiastic. I installed it on my laptop, it just worked. The feature set really fit very well with our solution already. It did all the things that we had to do a lot of work for in the past, more or less standard. So yeah, well, we were excited. Not sure how it would scale. Back then 1.2 was the current version. It relied on rsync for replication, which does not work on Windows, but maybe also for a Linux solution it was not the most elegant way to do it. And we had a working scale-out solution for search, so, well, we waited a bit. And then as version 1.3 came out, well, we jumped in. We started planning. So we made a technical design plans for how to do it, and thought, well, maybe we should ask some experts here. So we talked to the people at J-Team. Their office is really close to ours. And they said, yes, your plans look fine. That's the way to do it. But on Windows, well, it should be possible. It's Java. It should run anywhere. But we have never done it at scale. You know, the memory models are maybe different than the disk. I don't know. So they were hesitating. So we're not really reassured by their reaction. And we have other systems running on Linux, so it was an option just to do it and have Solr running on Linux. But that would mean buying new servers, have a new server role in the system. Didn't really want to do that. So we decided to try it and do some rigorous proof of concept, testing, load testing, and have a very careful approach to the migration itself. So, what were we going to test? Well, our index size is not so big. It's only in the order of 1 million objects that we're searching. So we don't need sharding, we don't need all of the really complex stuff. But we do need scale out of the search of the searchers. So we have a large search volume. So we wanted to test that. How does replication work? How does replication work under heavy search load? And then in the end, we decided not to try to load test the whole system, but to load test the parts that we were not certain of, because it's just too difficult in our experience to emulate real user behavior. So, well, this is where we went wrong, of course. So we said, we know this system, it runs now, we're not changing the functionality, so it should be possible to think about where the problems might be if we migrate to Solr. So these were more or less the hotspots where in our previous experience, bottlenecks could occur performance-wise. So we thought, well, let's just check all those bottlenecks and see if we can imagine something going wrong there if we do it with Solr from now on. Well, there was a number of them that were not changing. So we're still creating HTML. There's still a lot of threads running for consecutive, for parallel requests on web servers. Our cache servers are constrained by memory, as they should be. That's all not changing, so fine. And there were a few points that we were not sure of. So, for example, reading the XML or JSON or whatever coming back from the Solr servers, how much CPU would the parsing of that cost? Maybe it's a lot. We didn't know. And then, of course, on the server side, there's I/O constraints, there is CPU constraints, memory maybe for caching. So we thought these were things that were really going to be different. We have to test that as well. This is the slide where we went wrong. I'll come back to it later. So, yeah, well, this is basically what I just said. We thought it should be possible to, I'll go back to this slide. Basically, on the server side, we were expecting, but we wanted to test it, but we were expecting that it would cause no problems because we were actually already doing this on these servers with a SQL Server database. Solr is just much better in doing these searches. So if you run it on the same hardware, we were thinking it should be enough. We shouldn't need to buy anything extra. And that was, of course, a very attractive proposition because there would not be, well, buying the servers is not the most, but renting extra space, management of them. So we went for the solution where we would not have new servers, not have new server roles, but install Solr on the machines that were already running SQL Server for doing the same thing. And then we went testing. So we stress tested Solr with our data set with representative search queries. We put 100 concurrent threads on it and went hammering. And it was no problem at all. One machine could easily handle the full load. So we were happy there. And then we stress tested the parsing code for the responses coming back on the client, or the web server really. And we decided, to be sure, not to use a client library that was around. I'll come back to that. But have our own really lean custom XML parsing. Also, no problem. So, well, we were quite confident that it would work. But because we are changing the core functionality of our operation here, we still chose for a careful adoption, meaning that we introduced Solr first for a non-mission critical part of the website, meaning the houses that were already sold. So we migrated first that part, and so we could, worst case, we could just disable it and fix it, and just keep running with the houses for sale that make us money. And make sure that we could roll back maybe to a previous version in the worst case. So that's what we did. And then the libraries, yeah. So in the .NET space, there are maybe not as much and not as mature libraries as in the Java space. I'm not sure about that. I've heard not so enthusiastic stories around me here these days about the Java libraries as well. So maybe it's wishful thinking, but I think that the support in the Java world is maybe better. There are actually two .NET libraries that act as a client to Solr. It's Solr Sharp and SolrNet. Solr Sharp is a bit older, widely used, but well, we had a look at the code. It didn't look very actively maintained. It didn't look so good, really. SolrNet looks better, is younger, looked a bit over-architected to me. Many inversion of control and solid principles and interfaces here and there, and which is all fine, but well, it looked like a big beast, and we only wanted to use certain parts of Solr, so we decided, well, okay, HTTP and XML, it's really not so hard, and we can do that. We do that all the time. So we rolled our own. Two things really. a very light parsing client, and a very light fluid API for building the URLs. And well, that was not so hard, but I'm in hindsight maybe not sure if that was the right choice, because now we have to maintain it. And of course, our solution is maybe also not so very good. I think we have some refactoring to do there eventually, and we might as well switch to one of the standard client libraries in the end. Well, I'm not sure if I should recommend this, but the options are there. It's not difficult to do it, but well. So this is what we did. So no new servers, not running on Linux. We chose, by the way, we chose Tomcat as our application host because the operations people liked that it had a clean installer and could run as a Windows service, and well, it looked easy to them. So Tomcat, and it's fairly common, I think. So I have no opinion really. We went for the simple master-slave topology. The number of slaves was more or less by accident the number of servers that we were already using for the database solution. So let's take them all. Let's not make differences between the machines or anything. Introducing it on a non-mission critical part, and not using available client libraries, but do it ourselves. So what happened? First we did the non-mission critical part. Worked like a charm. Everybody happy. Operations very happy about the stability of the system. The responses were very fast, so really good. So we decided after a few months in production, we said, okay, let's do the rest. So did not went so well. When I proposed this talk, we were actually 2 weeks before going live with this, and I was fairly confident that it would just be a great story with only successes. And then we went live and everything broke down. Everything became really slow. Everything, not only searching or Solr, even pages that didn't even use Solr became really slow. CPU looks fine, memory looks fine. We have been spending 3 really bad days finding out what was wrong. We found out really fast that it was related to a bandwidth, internal bandwidth. And so we were able to move things around a bit and reinstall quickly in other places, and eventually it worked. So we haven't had bad downtime, but we had to disable a few functionalities temporarily, and we had a really stressful week. And what turned out was our problem was that because we had started with the bottlenecks in our system that we knew, and never realized that there might be others. Well, it's really stupid. In hindsight, I mean, we should have thought about this. It's not rocket science. But we just didn't think about bandwidth between the servers and the clients. And it turned out that our switch in the network had some gigabit ports and some 100 megabit Ethernet ports. And the bandwidth needed for that uncompressed XML that was returned from Solr was slightly over 100 megabit per server. So it choked the network, and it also choked the communication from our web servers to the caching servers. So everything using anything from the network, over the network, was choking. And then when we were thinking about a solution quickly, we thought, well, maybe we should enable compression on the XML. So it's easy to do that in Tomcat. But then we found out that our own rolled library on the client didn't support compression. It's really easy to do that in .NET, by the way. You do it like this. The standard HTTP web request class of .NET supports compression, but you have to enable it. You have just to say, okay, use gzip and or deflate, and then it will add the correct accept headers, it will decompress the results. It's really easy, but you have to do it, and we didn't. So we were, well, the only thing we eventually could do was make sure that the bandwidth was there, and we managed to do that, so I still have my job, but it was really bad oversight. So let's look at some numbers. Maybe these are numbers that you can show to potential customers to convince them that it should work. To really have a value from the numbers, you have to know some context about our schema and the kind of queries you do. So let's first look at that. Our main core has 138 fields. So this is a lot. It's partly because the data is it's migrated from the old system that had a lot of columns. We did combine a number of them into simpler columns, but I think if we went from the ground up, we would have had less fields, but maybe not many less. It's complex data, and we know a lot about these houses, and you can search on a lot of things. So, okay, 138 fields, of which 127 are indexed, 12 are multi-valued. We mostly use the older field types, so str field, sortable int, sortable float, boolean, and no try fields. That's because one of the requirements in our system is that if you, for example, if an estate agent does not submit information to us about the surface of an apartment living area, then we all, and if someone tries to sort on surface area, we always sort them at the bottom. So whether you sort up or down, they always should be at the bottom because we have no information. And this is something that try fields can do. The old fields had this sort missing last, sort missing first properties. They're not supported yet by try fields. I'm really interested if they will be supported in 4.0, but the Jira issue is still open, so not sure. So we use the old fields. So I guess that if you don't use those, performance would be slightly better. Then we have no full text searches. We have no stemming and tokenizing and all of that. So that makes it a bit easier. It's very much slicing and dicing and just our tokens are very strict. So if you search for near to park, we just search for near to park, and the text in that field will always be exactly that. It's very non-fuzzy. So our typical query returns all of the fields. Now those are a lot of fields, but most of them are empty. They're quite sparse, but each object will have about 40 fields filled at the least. So, well, we just return all fields. We have, in one query, we return 15 documents. We have 13 field facets and 37 query facets every time. And then because we don't have any stemming and full text stuff and that, we only use FQ filters. So there's no, we do Q equals star colon star, and then add a lot of field query parameters to the URL. And we, except in a few cases, we don't have scoring and boosting and all of that. It's very straightforward, and we have a strict sorting order that is part of our business rules, and that we cannot just have any magic in, so, well. Then we have about 1.4 million documents in that core, and that takes about 1.7 gigabytes, so it's a fairly small index. We were surprised how small it was. It's only 1,300 bytes per document, which is mostly because the tokens are so the same. The diversity of the tokens is very small. There's no full text in there, so it's really efficient in the index. At peak times, we handle about 300 Solr searches per second. On peak days, that would be maybe 400. There are certain days in the year when there are events around buying houses organized, and we typically see a higher load, but 300 Solr searches per second is about what we do every evening. And then we have these cache hit ratios. The first one, result cache hit, the result cache, is very low. It says here less than 1%, but I actually think that it's 0. I'll come back to that later, why that is. It shouldn't be that. It should be a bit higher, but we do something strange there. Document cache hit ratio is about 30%, and then the field value cache and the filter cache, they're working really well for our solution. 99% cache hit. So, well, we mostly work in memory. We do incremental updates every 10 minutes. It's fast enough for us. I guess if we had a requirement for it, we could do it every minute. The volatility of the data is not so high, so we can easily do this. And every night we do a full index. It's only 1.3 million, 1.4 million documents, so we can afford to do full indexes regularly. And we're still, yeah, I'm actually happy that we can do that. I'm not sure why. It should work with only incrementals, but, well, it feels better. And there are actually certain situations where the incrementals just don't do it. For us, that's our fault. It's not Solr's fault. Replication, the part that bothered us the most about maybe that it would not be as stable on Windows, it works like a charm. It has never failed us. We do see that memory use of the searcher is higher during replication because there are two cores at the same time and then the cores are switched. But there is no hiccups, never. It just automatically worked the first time. Really happy about that. And I think it's the part that is maybe most operating system related of everything Solr does. The sharding, for example, is much more a logic thing and maybe less, well, the juggling cores, that's what I was worried about most. Works fine, really happy about that. So let's have a look at some graphs, because we were hoping that the resource use would be a bit less after introduction. So here you see of one of those database servers that now also runs Solr. It still runs the database. The database is still there. So the first red line, ignore the second red line. It's about the first red line. The first red line is our release. Before the red line, you see the typical CPU usage of those database servers. Normally, database servers are mostly I/O bound page reads, but our database servers were also CPU bound because of the summing all the time. We were summing and summing and summing. So the CPU was actually doing quite a lot in those databases. And then you see a few weeks of wild changes, of us tweaking and trying to find a way to have everything up again. But after 2 weeks, you see the normal new standard line of operations, and you can see that the total CPU usage of the servers is now actually, well, maybe 2/3 of what it was. But in that CPU usage, there are now 2 processes running, or, well, of course more, but these are the more important processes. And they're SQL Server and Solr. And here you see a typical CPU graph for one evening. The evening is our busy time. The red line here is Solr, the green line is the database. We think that the spikes in the database are caused by updates. When we do updates in the database, sometimes we do more batch-like updates, and in the database solution, we used to have many indexes. So updates were very heavy, searches were cheap, updates were very heavy. So the spiking in the database here is probably updates. As you see, Solr runs a lot smoother, of course, because this is a searcher, and the searcher doesn't have to index. If you have a look at the indexer, you see every 10 minutes you see a huge spike, but well, that's what it's for. So we see that Solr is running at about 10 to 15% of CPU on those machines. The conclusion is really that it could run on one machine, because we have 4 of these machines. It could run on 1, well, maybe 2 for availability and failover. I think we will in the future. We have been decreasing our server park over the last years a lot because stronger processors, better software. I think Solr will enable us to add nicer functionality easier, and we might have the opportunity to remove another server and decrease cost. Oh, yeah. I have one thing to say about caching. We already had a memcached distributed cache in place, and we use it very intensively. And we used to use it for caching the results of all those facet queries. Actually, without the caching, the faceting would have been impossible in the old solution. It would have been way too much for our servers. When we went live with Solr, we turned it off because our reasoning was that Solr would probably do more efficient caching than we could do in memcached, because Solr can do partial results caching, and the only thing we could cache was the full result of the query. So that's like a result cache. Result caching is maybe not as interesting as a field caching or index caching. But currently we have turned it on again because it uses less bandwidth. So one of our emergency measures was to turn on caching again so that at least the most requested searches would not have to come as XML over the line, but as a compressed, small memcached, well, it's actually a binary encoded .NET serialized object. It's a lot smaller. What we see is that we have about 25% hit ratio there. So this is outside Solr. So before we go to Solr, we check the cache, 25% hits. In these cases, we don't use the bandwidth of Solr, but we go to memcached and get the results there. So this is why the result cache of Solr reports a 0% hit ratio, because if we did do very recently that request, we will not even go to Solr. What we do see is that indeed Solr would do it faster. So the Solr requests are faster than looking it up in cache, deserializing the stuff from the cache, all of that. There are a little bit more network latency hops involved there. Performance would be better if we just use Solr. For now, for bandwidth reasons, we do use the caching, but we will turn it off again later. So, wrapping up, Solr works fine on Windows. It's stable. We have had a lot of issues, but they were not related to Solr per se. It was more related to doing a big project, rebuilding the core functionality of our system, and not thinking about certain things that we should have thought of. But Solr is fine. I can recommend it to everyone. If you are on the .NET platform, think carefully about the client libraries, because rolling your own is maybe tempting, because it's not so difficult what you do, but, well, in scale, in doing lots of requests, in making sure that you dispose everything that you should dispose, and that you can enable compression, and that you can support chunked responses that you will get if you turn on compression, and all of those things, it might be a little bit more complex than you first think. So maybe a widely used library is a good idea. But I cannot really recommend any at the moment. Have a look at it if you go there. And think of bandwidth when you're doing capacity planning for your migration. So you can think of maybe not using XML but JSON, or which is a lot smaller. Or make sure that you have the CPU available to just always run compressed. We don't have Java bin serialization available, of course, on the .NET framework. That would help. But, well, alas. That's it. This is me. Feel free to ask questions. The question is, I mentioned running it on one machine, and Windows is known not to be as sophisticated as, for example, Linux in prioritizing processes, especially also for the I/O. That's what you're referring to, right? The I/O resources, yeah. And the question is, would that be a problem to have the indexer and the searcher running both on one machine? Yeah, our experience is that you shouldn't. I was referring to running all of the search on one machine. The indexer is, yeah, it does use a lot of I/O and CPU. I'm not sure if that, we haven't really tried it, but I wouldn't recommend it. Also, the kind of machine you would use for indexing is actually quite a different one than searching. Searching, you want to scale out, you want them to be really simple and load balanced, and the indexer is maybe more like a back-end process. Maybe I never thought of running that on the same machine, actually. The question is, did you try an SSD disk for indexing? Yes, we did. Actually, the machine that we're indexing on has an SSD disk. But we didn't really benchmark or compare. We just thought, well, it's probably better to do it on a fast disk. We haven't done many optimizations in performance anyway. I'm quite sure. For example, we're still running on Solr 1.4. And we have done some tests with the current Solr version, and we have seen that indexing becomes a lot faster for us. Especially the commits become a lot faster. But we haven't had the urge. It performs fine for us, and the 1.5 hour waiting at night doesn't bother anyone a lot. But yes, I think that the indexer is both CPU and I/O bound. So adding more and more IOPS to that machine will not get you faster and faster infinitely, but yes, fast disk is good. Anything more? Okay, so just to be clear, I'm not recommending to do Solr always on Windows. If you're starting from scratch, I think, and you have no predispositions of any kind, it's probably best to do it on Linux because, well, that's what it's best tested on. It's most widely used. But if you have any reason to run it on Windows, don't be scared. It works. It works fine. Thanks.